Hello everyone, my name is Peter Schaknat. I'm the Managing Director of Schaknat Electronic GmbH, and today we're going to optimize an MP2 Actros 2646. We have a beautiful MP2 Actros dump truck here. As you can see, it's already done quite a bit of work. Today, the customer wanted to do something good for it again and decided to give it an engine and transmission optimization. So here we have a Mercedes-Benz Actros MP2. People always say MP1, MP2, MP3. You can recognize the MP2, for example, by this continuous sun visor up here on the cab, which shows it's an MP2 chassis. It's a 2646, so it has a base power of 460 horsepower and 2,200 Newton meters of original torque, 11.9 liters, engine code OM501. So as I said, it's 11.9 liters, which is the second most powerful in its class. The engine is available from 330 to 480 horsepower. So it's really all the same engine. It's a V6 engine. Mercedes used a V6 in this series. Back then, Mercedes built both V6 and V8 engines in this series. That's no longer common today. Nowadays, there are hardly any V8s left. Apart from Scania, almost no one builds V8 engines anymore. That's also for construction reasons, because straight six-cylinder engines are simply easier to build, since you can use a modular system for different displacements. It's easier for manufacturers and better for customers. That way, you can, of course, save money as well. This is an old intelligent shifting system, so with a clutch pedal where you can pre-select the gears. I think it's a really awesome transmission. It's click, 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 pre-selecting the gears. So it really was a very good series back then as well. I've already explained in other videos that the only weak point with these engines, so everything with plug-in pumps, meaning pump, line, nozzle, is that the injectors have problems. That's why I say it's important with these engines to replace the injectors in time, because otherwise the spray patterns won't be 100% correct. Back then, with the 501 and 502 engines, there were always these holes in the pistons, and that was actually due to the injectors. The truck has just under 700,000 to 750,000 kilometers on it. The injectors haven't been replaced yet. That's why I'm personally interested today to see what actual output we have now. I think, regardless of what we measure now, if the injectors aren't right here, you can easily lose 50 or 60 horsepower. You can really notice that drop. You can also hear this in the sound that the engine is making. Furthermore, you can also see it at the vehicle's exhaust pipe, just so customers understand. If you happen to notice a slight soot buildup that progressively gets worse over a period of time, that is usually a clear indication that the fuel injectors are in fact damaged. But overall, these are really top-notch engines. Back then, the fuel consumption figures were also very good. Now, the customer said, I want to do something good for the car again and have it checked over once more. Overall, to see if the injectors have any issues or if the turbocharger is still working properly, that's what we're going to do now with the measurement. You can see from the chassis, it's a 6x4, so there are two driven axles again. It's a tipper chassis, so it's meant for construction site use. So you can see it here with the external planetary gears. We're measuring at this wheel here again. So actually on this one, 10 centimeters here, this is where we're actually measuring the power again. The last axle spins freely. In any case, we're going to measure the wheel power. I can show you both engine and wheel power, so I can once again illustrate the ratio, what actually gets from the engine to the driven axle, and what is actually lost as power loss, so you can get an idea of how much energy the drivetrain consumes. Because as I said, external planetary gears are it's the heaviest axle there is, but also the most robust. That's why it makes sense, especially in the modular sector. Andre has already unfastened it. I'll move it away at the back. We've pulled the axle down with the hydraulic cylinder, so we don't have any traction problems. We are conducting this measurement with the differential locked, which means the rear wheels are forced to turn at the same speed. This setup allows us to accurately calculate the total parasitic loss. That's why you can see the last axle spinning freely. They don't measure me, that's why we only have the eddy current brakes here. All right, everything explained so far? Now we'll do the initial measurement, then we'll read out the vehicle, reprogram it, do the final measurement, and then parameterize the clutch. The old intelligent ones, you could also teach them well in terms of the clutch, which definitely benefits the cars as well. Then I'd say let's get started and we'll see each other again at the monitor. We've now completed the initial measurement. We still strapped down the front axle so we could measure in four-wheel drive, making sure all wheels were driven because there were some issues with the ABS switch since the front axle wasn't being powered. All right, so now that we've locked it anyway, powered all of the wheels, and have officially taken the measurement, let's go ahead and take a quick look at the initial output. I have to say I'm actually curious myself to see what kind of initial power it has. I'm honestly surprised. This thing has 750,000 kilometers on it and still the original injectors, and it's still putting out almost 460 horsepower, specifically 458 and 2,229 Newton meters of torque. You can see it down here in the diagram, and the other guy mentioned it too. My engine, when accelerating out, you can really tell that something's missing, that it's weak. We'll take a closer look at that in just a moment. You can see it down here. We're looking again from 800 to 2,000 revolutions per minute. Here on the left, we see the horsepower axis, and on the right, we see the torque axis. You can see here, its maximum torque is actually at around 1,200 revolutions, which is relatively late. It should really reach that at 1,000 revolutions already, and that's exactly what the customer is complaining about, or what the other person at the test bench notices, that it just doesn't really get going at low revs. And that's exactly where cars start to consume fuel. When they get into the lower rev ranges, you constantly have to shift down. That's what actually makes the engine inefficient, because a diesel engine really relies on torque. And that's always a very simple formula. Every revolution needs a fill. Low revs mean low fuel consumption. Now we're going to try to adjust the torque down here so that it runs linearly. Of course, maximum torque. If we can get around 200 to 300 Newton meters, we'll try to get more, and then up here we'll go back to stock settings. But not too much either, because the customer wants to keep driving the car for a long time, so we don't want to overstrain the engine or transmission and cause excessive wear. Still, I told him he should definitely have the fuel injectors replaced. If you already have a good initial performance, the injectors will make it run in a completely different way and be much more efficient in terms of its fuel consumption. All right then, so I would say Andre will take you along with him now, show you exactly how to extract the data, upload it for me, then we will program it upstairs and flash it back into the vehicle, and then we will meet again for the final output measurement on the monitor.
So let me show you how everything works here. To access the MP2, or rather, to read out MP1, MP2, and MP3 via OBD, we need a special cable. This can't be done with a standard OBD cable. Let's go ahead and get inside this beautiful Daimler. Here we have our OBD interface. It's always important for us, of course, so that we can read out the crucial data from the control unit. For me, this is now standard, so I particularly enjoy optimizing the vehicles because the process is very simple, very quick, and the customer notices a huge difference and is extremely happy after the test drive. So what I'm doing now is actually just backing up the data, something like an immobilizer, etc. If while writing, when we later redescribe the map, if something should get lost during bit communication, after all, millions of tiny zeros and ones are being rewritten, and if a sequence of numbers gets mixed up, then of course we have a problem and the truck won't start. Once we've read our important data like the EEPROM, we then read out the map. That also takes about 2 minutes, but thankfully it goes pretty quickly here. If you can put it that way, with the older vehicles, older in quotation marks, the map file is about the size of a music track. You could imagine it like an MP3 file, and with the new vehicles, it's already 4 times as large. So there's really a big difference in what's been added. just all the emission relevant maps alone. All right, perfect. Now I'll read it out. It takes 2 minutes. The progress bar will run through and then we'll see the same office. So what's important for me is that I've now read the data status and now I'll send it to Peter. When I'm out in the field, I also have my laptop with me, no matter where we are. Then I just connect it like a USB stick. For that, I'll take you with me into the development room. So now I just read it out like a file. Then I send it to Peter. Peter will then reprogram it so that we really do save fuel, but also have nice torque at the lower end and still a more responsive truck. Because the thing is, we have construction site use here, large axles, and then the outer planetaries are also locked. And especially the older vehicles get a bit weaker and a bit more sluggish with every update. And we're going to fix that now, and then we'll see it right away on the test bench. So here I am again. Peter has now sent us back the modified file. I've now loaded it into my Genius device here. With the Genius, I can now decide, so to speak, that I want to write this file into the engine control unit. And since we're quick and want to get going fast, I'll do this partially now. I'll take you along for this now. So let's connect once. Over here, the ignition. Perfect. The ignition. So now it's loading here. We have an hourglass symbol. Then the right function comes up. Mod 12 is our internal designation for the software here. Now we have some important information here again, like OM501 LA. That's the engine, the software version, etc. and so on. For example, the spare part number as well. Now we click OK. Continue writing. That's what I want to do. I want to write partially. Partial means only the small data blocks that we've actually changed. That way, writing to the engine control unit only takes a moment. I can't even drink an espresso in that time. So partial writing. Yes, for the protocol to function correctly, you need to connect a charger. That's a safety notice from the manufacturer of these devices. Control unit identification. This is where it retrieves the information again to make sure it's really what I read earlier. Now it wants me to turn off the ignition so it can switch between the bits more easily. Programming the control unit, FPF file mod. Now I have to turn off the ignition again because this control unit is written when the ignition is off. This goes really fast, as you'll see in a moment. Now it's already starting. It actually takes 22 seconds. The control unit was programmed correctly. Perfect. That's exactly what I want to see. Confirm. And then let's start the OM501. This is just unbelievably amazing. Not to be compared with the howling Euro 6 engine. And then we'll see each other again for the baseline measurement.
We've now done the baseline measurement. Let's take a look at it together now. You'll see it here again, just briefly. Again, from 800 to 2000 revolutions at the bottom. There we see the same RPM again. You can see the pink curve down here. That's the original. And the pink curve at the top is the original horsepower output. Down here we always see the torque, and above that, shown linearly, the increasing horsepower as the RPM rises. But we're not really interested in the horsepower. For us, it's always the torque that matters. As already mentioned, the diesel engine lives off its torque. As you can see, we have a significant change from 460 horsepower up to just under 522 horsepower. So that's a total of 80 more horsepower. Now, that's about what I would usually say is optimal for this particular engine. And just under 300 Newton meters of torque. That's also something I've found out over the past few years. When you have exactly these 300 Newton meters more, the cars are best in terms of fuel consumption and wear. That's when they have the least problems and run the most reliably. So, very briefly about the performance curve. I said I would like it to pull through more linearly here so that it is able to reach its maximum torque a little bit faster, but down here it still somehow gets choked off. Now, by reading out the milligrams per stroke, I have seen that it simply cannot manage the necessary amount down low. That could be exactly the problem with the injectors. So I would say once the customer has replaced the injectors, we'll probably be able to get much better torque at the lower end just by adjusting the settings. So I think once we have it on the test bench, I'll have to talk to my customer. Maybe in 2 or 3 months, if we measure it again on the test bench, the curve will automatically be better at the bottom, simply because it can't deliver the amount right now. Through lambda correction, so that it doesn't start to smoke, it simply begins to limit itself at the lower end. To limit itself, but still, the curve is clean, it's a top result. I would say with the torque, I'll definitely be able to save 3 to 4 liters of fuel in operation. So as I said, I'm really happy with the result. With the injectors, I'll have to take a look. Maybe we'll make a separate video about that once the injectors have been replaced, so you can actually see the differences and what happens then. So I'd say, to finish up, let's parameterize the transmission. For the clutch, we have a learning process via a combination on the gear lever. We'll do that now, then the shifting will be much better again, and the clutch will engage more smoothly. And with that, we're basically done with the engine and transmission optimization. We've reached the end of our video on the engine and transmission optimization of the MP2460 Actros. As you can see for yourselves, considering the mileage and what we did in the initial measurement today, it's impressive because I honestly expected it to have less power, since with that kind of mileage, the injectors, wear and tear, and the turbocharger usually mean they have less. But it can also be the case that if the vehicles are well maintained, regularly serviced, and everything is done properly, oil changes and all that, they can actually retain their performance. If you're interested in this topic of engine and transmission optimization, feel free to check out our website at www.schaknat.de. We're also happy to advise you by phone, or you can send us an email or a WhatsApp message. Thank you for watching. See you next time. Take care.